This is the complete design of an agentic AI system. Every box on the screen has a job, every arrow means something, and by the end of this video, you will understand all of it. You've probably heard that AI agents are changing how software works. Machines that don't just answer questions, but actually get things done. They book, they research, they write, they fix. But strip away the hype and an agent is just a system, a handful of components, each one solving one specific problem, connected in the right way. So let's build one piece by piece, starting from a blank canvas. Agentic AI system design, the complete big picture. Part 1, the core. Every agent, no matter how sophisticated, begins with the same component at its center, a large language model. And to design good systems around it, you need an honest picture of what this thing actually is. At its heart, a language model does exactly one thing. Given some text, it predicts what comes next. You write the capital of France is, and it completes Paris. You write the first half of an email, and it suggests the second half. One word at a time, that's the entire trick. Now, that sounds far too simple to matter, but here's what surprised almost everyone in the field. When you train that prediction engine on a large fraction of everything humans have ever written, strange abilities start to appear. To predict the next line of a broken program, the model has to internalize how code works. To predict the ending of an argument, it has to follow the logic, so the model can draft emails, write working software, explain difficult ideas simply. Even reason through problems it has never seen, step by step. At sufficient scale, prediction starts to look a lot like thinking. The most useful mental model is this. Treat it like a brilliant new employee on their first day, extremely well-read, surprisingly capable, and completely unaware of anything specific to you, your company, or today's date. Because a model on its own has 3 built-in limits, and the entire rest of this video is about fixing them. Limit 1, it is frozen in time. It only knows what existed in its training data, and the world has moved on since. Limit 2, it has no hands. It can describe sending an email in perfect detail, but it cannot actually send one. All it can do is produce text. And limit 3, it forgets. The moment your conversation ends, everything you told it is gone. Keep those 3 problems in mind: frozen, handless, forgetful. Every component we are about to add exists to fix one of them. Let's place the first box on our canvas. Part 2, instructions. A raw language model will happily talk about anything in any style at any length. Ask it a question and it might answer in 3 words or 3 pages. For a chat toy, that's fine. For a product, that's a problem. So before an agent ever sees a single user request, its designer hands it a set of standing instructions. Sometimes called a system prompt, it reads like an employee handbook written for a machine. You are a customer support agent for this airline. Be concise and warm. Always check the booking before answering. Never promise a refund without running the policy tool first. These instructions define 4 things: the agent's role, what it is and what it is not, its rules, the hard lines it must never cross, its tone, how it should sound, and its process, the order in which it should work. The same underlying model becomes a careful legal assistant, a patient math tutor, or a blunt code reviewer, purely based on what this one document says. And the effect is dramatic. Ask a raw model about a delayed flight and you might get a generic essay about air travel. Give it instructions first and the same model checks your booking, quotes the actual policy, and offers you a rebooking. Same brain, completely different behavior. Instructions are the cheapest and most underrated part of agent design. There is no training involved, no new infrastructure, just careful writing, refined over time as failures teach you what to forbid. A single well-placed sentence can prevent 1,000 failures. So that's our second component, instructions feeding directly into the core. The system is starting to take shape. Part 3, tools. Our model can think and it now knows how to behave, but it still cannot do anything. It has no hands. This is the component that changes that. And honestly, this is the moment a chatbot becomes an agent. The mechanism is called function calling, and it's simpler than it sounds. The designer gives the model a menu of available actions, each with a name and a description. Search the web, run this code, query the bookings database, send an email. When the model decides it needs one of them, it doesn't reach out and touch anything. It simply writes a short, structured request, called the flight search tool, destination, Tokyo, date next Friday. A separate piece of software called the runtime reads that request, executes the real action out in the world, and pastes the result back into the model's context. To the model, it feels like magic. It asked a question, and the answer simply appeared in front of it. Then it reads that result and decides what to do next. And that simple exchange creates something powerful. A loop, watch it work on a real task. Find me the cheapest flight to Tokyo. The agent reasons, I need prices first. It acts, search flights. It observes 3 airlines and the cheapest has a 14-hour layover. It reasons again. That layover is brutal. Is it worth checking nearby dates? It acts again. Around and around, reason, act, observe, until the job is done. This loop is the heartbeat of every agent you will ever use. When you watch an agent work for 2 minutes before answering, this is what's happening. Dozens of trips around that circle, each one informed by what the last one found. And notice something important, the model never touches the world directly. Every single action flows through a tool that the designer chose to include, shaped exactly how the designer allowed. No email tool, no emails. Read-only database access, no deletions. That boundary is not a limitation. It is the single most important safety feature in the entire design. So tools go on the canvas with arrows flowing both ways. The agent acts and the world answers back. Part 4, Knowledge. Remember the first limit. The model is frozen in time. It has never read your company's documents. It doesn't know your prices, your policies, or anything that happened after its training ended. Ask it about your refund policy, and it will either admit ignorance or, worse, invent one that sounds plausible. The fix is called retrieval, and it works like a well-run library. Your documents get indexed ahead of time. Manuals, policies, reports, databases. Then, when a question comes in, the system searches that index for the passages most relevant to this exact question. Not by matching keywords, but by matching meaning. A question about getting money back finds the refund policy, even if it never uses the word refund. The top passages, maybe half a page of text, get placed directly into the model's context, right next to the user's question. And now the model isn't answering from stale memory. It's reading from the current source, handed to it at the last second. This technique is called Retrieval Augmented Generation, or RAG, and it's how agents stay current without ever being retrained. Update the document, and the very next question uses the new version. The model doesn't need to know everything. It needs to be handed the right page at the right moment. Retrieval has a second benefit that designers care deeply about. It grounds the agent. When answers must be built from real retrieved passages, the model is far less likely to make things up, and it can cite its sources so you can check. So knowledge joins the canvas, feeding the core from below. Our agent is no longer frozen in time. Part 5, Memory. Everything a model is currently thinking about lives in one place called the context window. Picture it as a whiteboard. Your messages, the agent's replies, tool results, retrieved documents. All of it gets written on that one board. If it's on the board, the model can use it. If it's not, it does not exist. Here's the catch, the whiteboard has edges. A long working session will eventually fill it completely, so agents manage short-term memory deliberately. When the board gets crowded, older exchanges get compressed into a brief summary. The full transcript of an hour of work becomes 3 lines. Customer wants a window seat. Budget is $800. 2 flights shortlisted. Room is made for what matters now. But some things deserve to survive after the board is wiped. Your name, your preferences, decisions made last month, what the agent tried before and what failed. That's long-term memory. A store outside the model entirely, where important facts are written down as they happen and retrieved back onto the whiteboard exactly when they become relevant again. It's the difference between a hotel employee meeting you for the 100th time and one meeting you for the first time every single time. Tell a well-designed agent you're vegetarian once, and every restaurant it books for you for months quietly respects that. Memory takes its place next to knowledge. Short-term and long-term, our agent no longer forgets. Part 6, Planning. Give an agent a small task, and the loop we built handles it beautifully. Give it a big one, and something more is required. You cannot organize a 50-person conference by just doing the next obvious thing over and over. You'll book a venue before you know the budget. So capable agents plan. Before acting, they take the large goal and break it into a tree of smaller tasks. Organize the conference becomes first, confirm the budget and the date. Then, in any order, find the venue, compare caterers, draft invitations. Each leaf of that tree is small enough for the loop to actually finish, and the plan makes dependencies visible. Invitations cannot go out before the venue is locked. Watch the same task run both ways and the difference is stark. Without a plan, the agent dives in, books enthusiastically, and paints itself into corners. With a plan, it moves in order, and when the caterer falls through, it knows exactly which branch to redo without touching the rest. Good planners do one more thing: they check their own work. After each step, the agent looks at the result and asks, did that actually succeed? Is this plan still the right one? If not, it revises and tries a different path. This habit of reflection, catching your own mistakes before anyone else does, is one of the biggest differences between a flashy demo and an agent you can trust with real work. The planner sits beneath the core, quietly deciding what to do next and in what order. The single agent is now complete. Part 7: Orchestration. Everything so far describes one agent, one whiteboard, one loop, but some problems are simply too big for that. A single context window cannot hold an entire market research project. That's when designers reach for a team. The most common pattern is the supervisor. One orchestrator agent owns the goal and does none of the detailed work itself. It breaks the project apart and delegates each piece to a specialist, a researcher with search tools, an analyst with a data toolkit, a writer who assembles the final report. Each specialist runs its own full loop on its own clean whiteboard and reports its findings back up. Teams unlock 2 tricks a single agent cannot pull off. First, parallelism. 3 researchers can cover 3 markets at the same time, cutting hours down to minutes. Second, verification. 1 agent can be given a single job, check the others. A verifier that audits claims, reruns numbers, and catches errors before anything reaches you. It works for the same reason a fresh pair of eyes works on human teams. The verifier isn't attached to the answer. But be careful, every extra agent adds coordination, overhead, latency, cost, and brand new ways to fail. Agents can misunderstand each other just like people do. The best designers use the smallest team that solves the problem, and quite often that team is one agent with good tools. The orchestrator takes the top of our canvas, directing everything beneath it. The architecture is almost complete, but the most important layer is still missing. Part 8: Guardrails. We now have a system that can think, act, remember, plan, and coordinate, which raises an uncomfortable question. What happens when it's wrong? And make no mistake, sometimes it will be wrong. The failures have patterns. An agent can hallucinate an action, confidently emailing the wrong customer with the wrong information, fully convinced it did well. It can loop forever, retrying a step that will never succeed at 3 in the morning, 10,000 times. It can quietly burn through a budget, one perfectly reasonable API call at a time. None of this is malice. It's a capable system, wrong with confidence. So mature systems are wrapped in guardrails, layers of them. Permissions decide which tools each agent may touch at all. Approval gates pause the risky moments. Anything irreversible, payments, deletions, messages to real customers, waits for a human to say yes. Hard limits cap how many steps and how many dollars any single run can consume, and filters check what comes in and what goes out. Here's the mindset shift that separates good designers from optimists. Good agentic design does not assume the AI is always right. It assumes the AI will sometimes be wrong and arranges the system so that being wrong is cheap. Small mistakes get caught by the verifier. Medium ones get stopped at an approval gate, and the catastrophic ones are simply impossible because no tool for them exists. Less like trusting a genius, more like managing a brilliant, slightly overconfident new employee. So we draw a boundary around the entire system. Nothing gets in or out without passing through it. This dashed line may be the least glamorous part of the diagram. It's also the reason any of this can be trusted in the real world. Part 9: The outer loop. One question remains, and every serious team obsesses over it. After you build all of this, how do you actually know it works? The answer is evaluations. Hundreds of test scenarios run against the agent every time anything changes. the angry customer, the ambiguous request, the tool that times out halfway through. Each run is scored. Did it solve the task? Did it follow the rules? Did it stay in budget? Change one line of the instructions, and the whole suite runs again. It's how you improve one behavior without silently breaking three others. And once the agent is live, monitoring takes over. Every real conversation is logged and studied. Where do users give up? Which tool fails most? What did the agent do in the weird cases nobody predicted? The failures found there become tomorrow's test cases. The missing capabilities become next month's tools. That cycle, measure, learn, improve, is the outer loop. The inner loop runs in seconds and gets tasks done. The outer loop runs over weeks and makes the whole system better. It's the final component on our canvas. And there it is, the complete picture. A core that thinks by predicting, instructions that shape its behavior, tools that give it hands, knowledge that keeps it current, memory that lets it remember, a planner that breaks big goals into achievable steps. An orchestrator that turns one agent into a team, guardrails that make mistakes cheap, and an outer loop that never stops making it better. 9 components, and notice each one exists to solve a real, specific problem. Frozen in time, fixed by knowledge. No hands, fixed by tools. Forgetful, fixed by memory. Nothing here is decoration. Every agentic system you will use or build or be pitched in the next few years is some version of this diagram. The models will get smarter, the tools will multiply, but the design will look remarkably like what's on your screen right now. We are moving from software we operate to software we supervise, and now you understand how it works. If this helped you see the big picture, consider subscribing. There's a lot more coming.